Hi, this is Mrs. Tellas. We're getting to do section 9.3, which is solving quadratic equations by taking the square root. So far we have solved them by graphing, and this is our second method. We've actually also solved in chapter 8 by factoring. So we've done factoring and we've done graphing, and now we're going to do solving quadratics by taking the square root. Okay, so solve without graphing. So what do we do first? First thing we do is we take this z or this y and make it a 0. And what we want to keep this x squared positive. So we want this negative 9 moved to the other side of the equation. So we're going to add 9 to both sides. So on the left side, that's going to give me 9, and over here it gives me x squared. So I want to take the square root now. So I'm taking the square root of this side and this side. And when I take the square root over here for x squared, that's x. And when I take the square root of 9, that is plus 3 or negative 3. So I have two solutions, 3 or negative 3. And this is only going to work as far as solving if it doesn't have a bx. If it does have a bx, that's not going to work anymore. Another way that we could do this, we could graph. We could find the vertex and set up a table, and then wherever y is 0, that would be where it crosses. Another way we could do it is we could solve by factoring. So this is a difference of squares, so x squared would be x at x, and the square root of 9 is 3. And since there's only terms, it's plus minus. And then we would change this to 0 and set both of these equal to 0. And we would get the exact same answers. So this one would be negative 3, and this one would be positive 3. Oops, positive 3. So we get the same thing if you notice, 3 or negative 3. We could also write this as plus minus 3. Or you could write it as negative 3 and positive 3. Okay, so here are the directions for solving square roots or solving quadratics with a square root. So you're going to isolate your x squared term, and then you're going to find the two square roots of each side, and you're going to simplify if you can. Okay, so isolate the x squared term. And this is, you can only use this when there's no bx. There cannot be a bx for us to do this. Okay? All right, let's go to the next page. Okay, so I've got a similar thing. Notice it's a perfect square or a difference of squares. There's no bx, so I can use solving, and it actually says solve the following problems using square roots. So I'm going to move the 16 over. Notice that 16 is a perfect number. So my x squared drops and it equals 16, and since it is now isolated the x squared, I'm going to take the square root, which is just x, and over here on this side it is plus or minus 4. So again, remember what the solution means. That means if I graphed the parabola, it would be crossing the x-axis at positive 4 and at negative 4. And that takes care of the directions for solve. Okay, same thing here, number 2. So first thing I would do would be to move the positive 36. Remember, I'm trying to isolate the x squared. So I'm going to pull the 4x squared down. Now I'm going to divide both sides by 4 because I'm trying to isolate that x squared. And then I'm going to take the square root. So my answer is plus or minus 3. Okay, number 3. Okay, so notice this has got two numbers in it. Looks a little different, but there's still no bx. That's important to realize. No bx. You cannot do this if it has a bx. All right, so I'm going to add 14 to both sides. So my x squared is going to drop. Those cancel. And over here I get negative 36. And then I'm going to take the square root because the x squared is isolated. So when I take the square root here, I get x. But if you put negative 36, the square root of, in your calculator, it gives you an error message because we can't take the square root of a negative. There's no number times itself that will give you negative 36. So the answer here is no solution. And what it means is that the parabola does not cross the x-axis. So it would be a smiley face above the x, and it would start above and it would continue to grow up, so it would never cross that x-axis. All right, let's try this one, number 4. Okay, so I'm going to move my 32 or my minus 32 by adding it. So those cross out, 2n squared drops on the left, and over here that becomes 0. So now I'm dividing both sides by 2 because I want to isolate the n squared, and I'm taking the square root. So n is 0. Now, plus or minus 0 doesn't really exist because if you have nothingness, it can't be a positive value or a negative value. It's nothing. So the answer is just 0, which means that the vertex is sitting at 0, 0. It only crosses one time instead of 2. Okay, let's do the fraction one. All right, so I'm going to make a t. Notice there's no bx term. It's number 5. So I'm subtracting 3 first. So 1/4 x squared equals negative 3. And then to get rid of a fraction, I would multiply by its reciprocal. So those cross out, and this is just x squared, which is what I wanted. I wanted the x squared to be alone. And over here, negative 3 times 4 is negative 12. So when I go to take the square root, I notice there's a negative in here, so this is no solution. Which means, again, the parabola does not cross the x-axis. All right, solve using square root. So we have the same thing. It looks a little different because it's got a perfect over here and it's got a perfect over here. Notice that this quantity squared means that there's 2 of them. That's what this x squared or this quantity squared means. It means there's 2 of them. So I can still take the square root on both sides. Okay, so I could do this a couple different ways, but let's do it this way. So we're going to take the square root here and take the square root here because we already have perfects on both sides. So if I take the square root of x minus 1 quantity squared, it would be x minus 1 equals plus 4 minus negative 5. It equals both of them. So here I would break the problem into 2. So x minus 1 equals positive 5 and x minus 1 equals negative 5. And then I would add 1 to both sides for both of them, and I would still come up with 2 different solutions, negative 4 and 6. Okay, questions on that? All right, let's look at the next one. It's very similar to that first one. All right, so I'm going to go ahead and move the 4 over because it's outside the parentheses and it's not squared. So I'm going to divide by 4 here and divide by 4 here. So this now is x minus 3 squared. And I really like 9 over 4 and not the decimal because they're both perfect. So I'm going to leave that as 9 over 4. You could change it to 2.25 because that's a perfect also, but I'm going to leave it as a fraction. I like the fraction better. So now that the perfect square is isolated, I can take the square root, both sides. So on the left, I get x minus 3. And on the right, I'm taking the square root of 9, and I'm taking the square root of 4. So in the numerator, I have 3, and in the denominator, I have 2. And there's 2 of them, plus or minus. So this is where I can set x minus 3 equal to both of those. So x minus 3 equals negative 3/2 as well. So there's going to be 2 solutions. It's squared, so that makes sense. So we're adding 3 to 1.5, so that's 4.5. And you can use your calculator on that if you want. And we're adding 3 here as well. So negative 1 and 1/2 plus 3 would be 1 and 1/2 or 1.5. Either of those work. Okay, questions? And if you had that as an improper, that would be okay. Okay, impropers are okay, decimals are okay, mixed numbers are okay. As long as it's equivalent to the correct answer, I'm good. All right, so on some of these, you're going to get, on some of these square root problems, unfortunately, they aren't perfect numbers. So, for example, on the first one, if I want to isolate the x squared, I've got to move the plus 8. So I'm going to subtract 8 on both sides. Now, this is different from what we were just doing because there's no parenthesis quantity squared. It's just the x is squared. So I need to isolate that x. So those cross out and I get x squared equals 11. Well, 11's not perfect, but I can still take the square root. I'm just going to need a calculator. So I'm going to take the square root here and here since x squared is isolated. So if you have a calculator like we have in class, we hit the second button, then x squared, and then I type in 11. And the directions say round to the nearest hundredths. So I get x equals plus or minus 3.316. Hundreds is 2 places over, so right here. So the 6 decides if it stays 31 or 32. So my final answer, rounded answer, it's actually an approximation, 3.32 plus or minus is my answer. Okay, same thing over here. Make my t. I'm going to move the 2 over by adding 2 to both sides. And then I'm going to divide both sides by 5. So I've got x squared, and I'm going to go ahead and make this a decimal. I'm going to make it a decimal because instead of a fraction, I just think it's easier. Notice 2 and 5, neither are perfect. It's not easy for me to just leave that a fraction. I have to take the square root of it. So I'm going to make it a decimal. So let's see, 1/5 is 0.2, so 2/5 is 0.4. All right, so 2 ABC 5. Let me just make sure that's right. 2 divided by 5 is better. Okay, so now we're taking the square root here and here. So the x, because it was isolated, I could take that square root. So now second, x squared 0.4 gives me a very long decimal, 0.632. I only need to go out 3 digits because I'm rounding to the nearest hundredths place, which is 2 places over. So it's either 63 or 64, and the 2 is a weak number. So this is 0.63. That's my answer. And it's plus or minus. Don't forget your plus or minus. I want you to pause it and try the third one by yourself and see if you get it, if you can. You're definitely going to need your calculator there. Okay, so first step is to add 30 to both sides. This is 34 on this side. And then second step is to divide by 3. Remember, my goal is to get that isolated. And I'm going to change it to a decimal, I think. Let me look. 34 divided by 3 is a repeater. So I'm not going to change it to a decimal. I'm going to leave it like that. Because I can't round right here until after I take the square root. Okay, so I'm going to leave it as 34 over 3. So now I'm ready, because x squared is isolated, to take the square root here and here. So second, x squared, 34 ABC 3. Enter. It gives me x equals plus or minus 3.366. Yeah. So I'm rounding here. So it's either going to stay 3.36 or go up to 3.37. And the 6 is a strong number. Remember, 5 and higher is strong. Under 5 is weak. So this ends up being plus or minus 3.37. That's my answer. If you got it, give yourself a pat on the back. It's got every element in it. It's got the add, subtract, it's got the divide, it's got taking the square root of a fraction, not forgetting the plus minus, it's got rounding, it's got all of it in there. Okay, so good job. All right, so now we have a story problem that has this there. Has the same kind of concept. So it says find the length of the side of a square with an area of 75 feet. So we know that a square has all sides equal. And we know that the area is 75 feet squared. So since these are both the same, I'm going to call them both x. So x times x equals 75. And you could call them s for side if you wanted. I'm going to call them x. Sometimes my s's look like 5, so I don't want to stay away from s if I can. So area equals length times width. So area is 75, length is x, and width is x. So 75 equals x squared. X squared is isolated, so I can take the square root. Now, it doesn't tell me where to round, but I have to round. I'm going to do nearest hundredths again. So the square root of 75 is 8.660, okay, or 8.66, and it's plus or minus. However, can there be a negative value for a length? Well, we both know that doesn't make sense. There can only be a positive value. So we're going to get rid of the plus or minus and just keep it as the positive value only. Now, we could take the 75 and we could simplify it. Rather than doing a decimal, we could change it to its perfect square factor and a non-perfect square factor. So the perfect square that I think of in 75, like quarters, would be 25 times 3. Well, I can take the square root of 25, but I can't take the square root of 3. So the square root of 25 is 5. And then the inside the radicals could say 3. So x could be 5 radical 3 to give us that 75 area if I multiply that 2 times. Let's see. A touch tank is in shape of a rectangular prism. Okay, a rectangular prism. Let's draw that. So I draw a rectangle and another rectangle, and I connect the sides. Okay, let's keep reading. It has a height of 3. Okay, it's 3 high. Its length is 3 times its width. So the long side of this is 3 times W, and the width is just W. And the volume of the tank is 270. So we're using volume here. So volume equals length times width times height. So we're going to plug what we know. We know the volume's 270. So 270, we know the length is 3W. We know the width is W. And we know the height is 3. So all I've done is draw a picture and use the volume from the problem and plug in for different particular letters in the formula. So let's go ahead and multiply over here. It's a big multiply mess. So 3 times 3 is 9, and W times W is W squared. So to isolate the W squared so I can take the square root, I'm going to divide both sides by 9. So 270 divided by 9 is 30. Yep, it is. Just checking my math there. And it equals W squared. And again, I want to take the square root here. So I can use my calculator. Second, x squared 30. It gives me 5.477. So if I'm doing a decimal answer, 5.48, and I don't want to do plus or minus because it's the width. Okay, width can't be negative. That doesn't make sense. And then my length was 3W. So 3 times 5.48-ish is 16.44. And then we already knew that the height was 3 because it told us that in the problem. So these would be my answers. Okay, now I could leave the answer as radical 30 instead of taking the square root and getting 5.48. So if I did that, because there's no perfect square in 30, think about it. 1 times 30, 2 times 15, 3 times 10, 5 times 6. There's no perfect number. There's no 4 times anything. There's no 9 times anything. There's no 16 times anything that will give us 30. So we could leave the width as radical 30. And then our length is 3W. So that would be 3 times radical 30. And then our height is just 3 because it gave it to us in the story problem. Does that make sense? Okay, I hope it does. Okay, we're all done. That was the hardest one. Here's your assignment. I think it might be different in big ideas. Take a look. No, I think it might be 5013 to 33 odds. Do whatever big idea says because that's what's assigned to you. But honestly, I'm not sure if that's last year or if that's this year. So I hope you have a good day, and I hope you understood. And if you have any questions, you know I'm online from 12 to 1. None of you guys ever come see me. So I'm hoping that you're doing okay and that you're understanding. So have a good weekend and take care. Bye-bye. Bye-bye.